What if the ground beneath your feet and the deepest, darkest chasms of space were speaking to each other? What if they were engaged in a conversation you could not hear, a dialogue written not in words, but in fire and gravity? For generations, we have lived with two fundamental truths. The first is that our world, our Earth, is a place of immense geological power, a cauldron of molten rock whose fury can reshape continents in a blink entirely of its own accord. The second, that the cosmos is a realm of silent, majestic indifference, a vast and empty stage upon which our small drama unfolds, noticed by none. But what if both of those truths were suddenly terrifyingly proven wrong? What if a whisper from interstellar space could awaken a dragon sleeping beneath our very homes? This is a story that begins not with a bang, but with a faint, almost imperceptible smudge of light against the infinite black. A ghost drifting in from the cold that lies between the stars. Its name is 3I, Atlas. The I stands for interstellar, a designation of profound significance, a cosmic brand that marks it as an exile from another sun, another solar system we may never see. It is only the third such wanderer we have ever confirmed in all of human history, a solitary traveler on an incomprehensible journey that has lasted for millions, perhaps hundreds of millions of years. Imagine its voyage. Cast out from its home star system by a gravitational game of billiards, played with giant planets, it was flung into the great void. For eons, it tumbled through a darkness so complete, so silent, that our own night sky would seem a blinding starstorm by comparison. It passed through dead star fields, skirted the edges of nebulae where new suns were being born, and navigated the gravitational tides of the galaxy itself, a tiny frozen relic of a world we do not know. It is a messenger in a bottle, a time capsule carrying the chemical fingerprints of its alien birthplace, a place that could be fundamentally different from our own. When our telescopes first caught it, it was just another faint point of light among billions, a suspect on a long list of potential comets and asteroids. But as astronomers at the Asteroid Terrestrial Impact Last Alert System, ATLAS, tracked its path, they saw something impossible. Its trajectory was not a gentle, familiar ellipse, the closed loop of an object tethered to our own Sunday. Instead, it followed a stark, dramatic hyperbola, the unmistakable arc of a thing that was not visiting but merely passing through. It came from a direction beyond the sun's influence, and it was heading back out into that same darkness, never to return. This tiny speck of ice and rock, perhaps only a few kilometers across, was a true alien, a physical emissary from another star's family, briefly gracing our neighborhood before continuing its eternal pilgrimage. We plotted its course, calculated its speed, and prepared to study this rare guest with every instrument we had. We expected to learn about the composition of other solar systems. We expected a spectacle. We did not expect it to be a herald. Because, as 3I, Atlas, began its long fall toward the inner solar system, something else began to happen. Here, on Earth, it started subtly, a statistical anomaly that at first went unnoticed in the planet's chaotic daily churn, a seismic tremor in a region of the Pacific Ring of Fire that had been quiet for decades. A plume of steam from a caldera in the remote Aleutian Islands, a mountain once thought to be sleeping a final permanent sleep. Then the rhythm quickened. In Indonesia, a country living on a knife's edge of tectonic fury, a series of eruptions began, more frequent and more violent than any in living memory, painting the skies with ash and forcing thousands from their homes. In Iceland, that volcanic heart of the Atlantic, a new fissure tore open the earth, not with the gentle tourist-friendly flow of recent years, but with a primal rage, spewing fountains of lava hundreds of feet into the air. From South America to Italy, from Japan to the deep, hidden volcanoes beneath the Antarctic ice sheet, the planet seemed to be stirring. It was as if a planetary fever was breaking. Geologists were baffled. Volcanic activity is notoriously cyclical and chaotic, but this was different. This was a global surge, a synchronization of subterranean forces that defied all conventional models. There was no single massive tectonic shift to explain it, no change in the Earth's core or mantle that could account for this worldwide unrest. It was a chorus of fire, with dozens of isolated instruments suddenly choosing to play in terrifying harmony. The planet's crust, which we depend upon for our very existence, seemed to be groaning under a new and mysterious strain. News reports filled with apocalyptic imagery, glowing rivers of molten rock, devouring forests, cities blanketed in a fine grey dust, and the haunting, beautiful yet terrifying spectacle of lightning storms generated within the towering columns of superheated ash. Earth, our solid and dependable home, felt as though it was becoming unglued from within its ancient thermal engine, revving for reasons nobody could comprehend. And then someone overlaid the two charts. On one side, the trajectory of the interstellar wanderer 3I, Atlas, as it drew closer and closer to the Sun, its path cutting nearer to Earth's orbit with each passing week. On the other, the graph of global seismic and volcanic energy release. The correlation was immediate. It was undeniable. It was utterly, terrifyingly impossible. As the alien object accelerated, the Earth's geological heartbeat accelerated with it. When Atlas crossed the orbit of Jupiter, 3 long-dormant volcanoes erupted within the same 72-hour period. As it neared the asteroid belt, a swarm of deep ocean earthquakes too far underwater to cause tsunamis, but powerful enough to be detected by every seismograph on the planet, shook the Pacific Basin. The lines on the graph marched upwards in near-perfect lockstep, a chilling duet between a tiny visitor from the stars and the molten heart of our own world. A coincidence, the experts insisted. It had to be. A profound, statistically staggering but ultimately meaningless coincidence. But the human mind is a pattern-seeking machine, and in an age of instantaneous global communication, that pattern became a signal, and that signal became a viral phenomenon. You've seen the headlines, haven't you? They flash across your screens, a mix of breathless scientific reporting and wild, unhinged speculation. Is an alien comet triggering Earth's volcanoes? Scientists baffled as interstellar objects approach coincides with planetary unrest. Your social media feeds are likely filled with it. Simulations showing Atlas's path, time-lapses of erupting mountains, and comment sections exploding with a digital babble of theories. To some, it's a sign, a celestial warning. To others, it's proof of a new and unknown force of physics, a connection between celestial bodies that our science has never dreamed of. And to many more, it is the herald of something far worse, a cosmic harbinger of doom, whose very presence is enough to shake our world to its foundations. The fear is palpable because this mystery touches upon our most primal anxieties. We are creatures of the surface, dependent on the illusion that the ground we stand on is stable. The volcano is a mythic monster for a reason. It is the planet itself turning against us. At the same time, we have always looked to the sky for portents, for meaning, casting the stars as characters in our human drama. Now those two ancient fears, the fury from below and the unknown from above, appear to have converged. The internet buzzes with fringe ideas that 3I, Atlas, is not a comet at all, but a disguised alien probe using some advanced technology to test our planet's geological weaknesses, or that it emits a strange form of radiation, an energy unknown to us that is exciting the magma beneath the crust. Or even in the darkest corners of the web, that its gravitational field, while weak, is resonating with our planet's core, in a way that our laws of physics say is impossible, a gravitational harmonic that is shaking the world apart. Science, of course, recoils from such explanations. In the quiet, sterile halls of our observatories and geological institutes, the official narrative is one of extreme skepticism. And it is a skepticism born of deep, hard-won knowledge. The fundamental forces of the universe are well understood. For 3I, Atlas to have any meaningful gravitational effect on Earth's volcanism, it would need to be orders of magnitude more massive as a large planet or a star, or pass so close that it would fill our sky. At its current distance and size, its gravitational pull on you is less than that of a passing airplane. The tidal forces it exerts on our planet are infinitesimally small, utterly lost in the noise of the much larger constant gravitational dance we have with our own moon and Sunday. There is simply no known physical mechanism, no force that we can write an equation for that connects a small, distant object with the deep planetary engine of volcanism. To the sober mind of a physicist or a geologist, this is a textbook case of apophenia, our tendency to perceive meaningful patterns in random data. They argue that we are living in an era of unprecedented geological monitoring. We have more seismographs, more satellites, more sensors watching our planet's every twitch than ever before. We are simply more aware of the Earth's natural chaotic volatility. Couple this heightened awareness with the arrival of a rare and exciting celestial visitor, they say, and our brains, hungry for a story, for a cause and effect, have forged a link where none exists. It is a grand illusion, a narrative we have imposed upon two completely independent events. It is a compelling story, a thrilling story, but it is not science. It is a phantom born from the marriage of data and fear, a ghost in the machine of planetary science. And yet, the data does not go away. The correlation persists. With each passing day as 3I, Atlas continues its inexorable journey into our skies. The planet continues to shudder. Every new eruption, every new earthquake that aligns with the object's approach adds another voice to the growing chorus of doubt against the official explanation. It chips away at the wall of scientific certainty. The world's greatest minds are now locked in a frantic, desperate race to understand. They are running simulations on the world's most powerful supercomputers, searching for any exotic physical interaction they might have missed. They are re-examining every scrap of data from past interstellar visitors, searching for similar overlooked correlations. The tension is no longer just on our screens. It is in the labs and universities themselves. It is the agonizing tension between what we know to be true about the universe and what our own planet seems to be telling us. This brings us, and you, to the heart of our investigation. We stand at a precipice of understanding, staring into a profound mystery. What is the truth behind 3I, Atlas, and the Earth's sudden fiery awakening? Are we witnessing a genuine physical connection across millions of miles of empty space? A phenomenon that will force us to rewrite our most fundamental laws of physics. Is this a cosmic threat, the first sign that our solar system is a more dynamic and dangerous place than we ever imagined? Or is this a story about us? Is it a reflection of a planetary distress that has nothing to do with the visitor? A sign that Earth's own internal pressures are reaching a breaking point, and we have simply found a convenient celestial scapegoat. Could this be the greatest coincidence in astronomical history? A fluke of timing so perfect it mimics causality? Or is it something far more unsettling? A profound misunderstanding, a global panic fueled by misinformation, and our own deep-seated need to find meaning in the chaos of the cosmos. The stakes could not be higher. To solve this puzzle is to answer one of the most pressing questions of our time. It requires us to journey to the farthest reaches of our solar system and to the deepest layers of our own planet. We must untangle the threads of data from the noise of fear and separate scientific fact from sensational fiction. The journey will take us from the volcanic frontiers of Iceland to the quiet, hallowed domes of our greatest observatories. We will meet the scientists, desperately seeking an answer, and the people whose lives have been upended by the planet's fury. The answers we find may be reassuring, or they may be deeply disturbing. But one thing is certain: before 3I Atlas disappears back into the interstellar night, it will hold up a mirror to our world and to ourselves, forcing us to confront what we truly know about our place in the universe and what we merely choose to believe. The clock is ticking. The object draws nearer, and the Earth continues to scream. What if our entire existence, our entire solar system is just an island, a single solitary island of light and warmth, adrift in an ocean of unimaginable scale, a cosmic sea of blackness stretching between the stars? For millennia, we have studied the familiar shores of this island, mapping its continents of rock and gas, charting the predictable tides of its planetary orbits. We believed we were alone in this tranquil bay, a self-contained system governed by the singular gravity of our Sunday. We were wrong, because sometimes from the great dark expanse something washes ashore. A message in a bottle from a star. We have never seen a traveler carrying secrets of a distant alien genesis. And in the silent, automated vigil of a winter's night, our generation's lookout spotted the third such traveler in all of human history. It did not arrive with a herald's trumpet or a fiery announcement. Its discovery was a whisper, a flicker of transient light captured by a sleepless electronic eye. On the frozen volcanic peaks of Hawaii and in the arid landscapes of Chile and South Africa, a network of sentinels maintains a constant watch. They are the Asteroid Terrestrial Impact Last Alert System, a name that speaks of a profound and sobering duty. We call it Atlas. These are not the grand deep-field observatories peering into the dawn of time, but wide-eyed robotic telescopes designed for a more immediate purpose, to scan the entirety of the visible sky every single night. Their mission is one of celestial cartography under extreme pressure, a relentless search for any rogue stone or icy wanderer on a collision course with Earth. They are our planet's digital watchtowers, their software programmed with the ironclad laws of orbital mechanics, the gravitational gospel according to Newton and Kepler. Every point of light they register is tracked, its trajectory, analyzed, its future path, plotted with cold mathematical precision. The vast majority of these detections are familiar faces, known asteroids on their regular beat, distant comets on their long looping journeys back to the cold. Their paths are ellipses, closed circles of gravitational loyalty to our Sunday. They are members of our family, however distant. But this new object, this faint smudge of photons, refused to conform. As the Atlas software ingested the initial observations, it began to draw the object's path through space. And the path it drew was impossible. It wasn't an ellipse. It wasn't even a parabola. The knife's edge orbit of a long-period comet stretched to its absolute limit. The line it traced was a hyperbola, a perfect, sweeping, open-ended curve. This single, elegant geometric shape was a more stunning declaration of alien origin than any radio signal could ever be. A hyperbola is not the path of a captive. It is the trajectory of a bullet fired from one star system screaming past another and destined to continue on into the void forever. This object was moving too fast, its velocity so great that the sun's immense gravitational grip, the cosmic anchor that holds Pluto in a 248-year embrace, was utterly incapable of holding it. It was not falling times around times the Sunday. It was simply falling times, past times it. For the astronomers who first saw that trajectory, it was a moment of profound, heart-stopping revelation. They were not looking at a piece of our solar system, they were looking at a piece of somewhere else entirely. A new designation was quickly assigned, one that carries with it an almost mythic weight, 3I Atlas. The I stands for interstellar. The 3 signifies its place in one of the most exclusive clubs in astronomy. It was only the third such object ever to be confirmed. Before it, there were only 2 other names in this extraordinary guest book. The first arrival in 2017 was one-I Oumuamua, a name that in Hawaiian means a messenger from afar, arriving first. And it was every bit as strange as its name. Oumuamua was a ghost, a fleeting glimpse that tumbled end over end, its brightness varying by a factor of 10. This suggested a bizarre shape, something perhaps 10 times longer than it was wide, a cosmic shard or needle. It had no visible coma, no gassy halo of vaporized ice like a typical comet. yet it was accelerating away from the sun, as if pushed by some unseen rocket engine. The mystery of Oumuamua was a scientific fever dream spawning theories from a hydrogen iceberg to a fragment of a tidally shattered world, and even in the far reaches of speculation, an extraterrestrial artifact. It was gone as quickly as it came, leaving us with a tantalizing and deeply unsettling puzzle. Then just 2 years later came the second visitor 2I, Borisov, and it was a profound relief. Discovered by amateur astronomer Gennady Borisov, this object was in almost every way a classic comet. It had a magnificent dusty coma and a long streaming tail. Spectrographs revealed its chemical makeup was remarkably similar to the comets born in our own system. Borisov was a crucial discovery because it proved that other stars build solar systems in much the same way our Sun did. It suggested that Oumuamua might have been the bizarre exception, not the rule. It was a comforting emissary, a piece of a distant solar system that felt reassuringly familiar. Borisov was the confirmation of a beautiful cosmic principle, that the ingredients for worlds, the ice and dust and organic molecules, are universal. It told us that comets, those majestic, ghostly wanderers, grace the skies of countless other suns. And now we had 3I, Atlas, the tiebreaker, the next chapter in this incredible unfolding story of interstellar contact. Would it be another baffling enigma, like Oumuamua, challenging our fundamental understanding of how objects form in the cosmos? Or would it be another reassuringly familiar comet, like Borisov, further cementing the idea of our cosmic normality? The entire astronomical world held its breath, turning every available instrument towards this faint, incoming speck. Because to understand the significance of this moment, you must first understand the profound difference between the celestial bodies we call our own and these messengers from the deep. Our solar system is a sprawling, structured and ancient place, filled with the leftovers of its own violent birth. Closest to home we have the asteroids. These are the bricks and mortar of planetary formation, the primordial rubble that never quite managed to coalesce into a full-fledged world. They are relics of the inner solar system, baked by the sun for 4.5 billion years. Mostly rock and metal, they are the solar system's geological fossils, ancient, quiet, and largely unchanging. They are time capsules of a dry, hot history, orbiting in a great scattered belt between Mars and Jupiter, a gravitational boundary line separating the rocky inner worlds from the gaseous giants beyond. Further out in the frigid darkness past, Neptune lies a second, far more ghostly realm, the Kuiper Belt, and beyond it, the theoretical Oort cloud. This is the domain of the comets. If asteroids are the bricks of the solar system, comets are its snowballs, its deep freeze archives. These are not baked barren rocks. They are pristine conglomerates of ice, dust, and frozen organic compounds materials, preserved in a state of cryogenic suspension since the moment of their creation. The Oort cloud is a vast spherical shell of trillions of these icy bodies, a celestial halo surrounding our solar system at a distance of nearly a light-year. It is the sun's ultimate frontier, a reservoir of primordial material so far away that the stars of the Milky Way exert as much of a gravitational pull as our own Sunday. Here, in the absolute zero of interstellar space, these cometary nuclei drift in a silent cosmic ballet. But occasionally, the gentle gravitational nudge of a passing star, or a chaotic jostling among themselves, can send one of these icy relics on a long, slow fall toward the inner solar system. For centuries, for millennia, it journeys inward, and as it crosses the orbit of Jupiter, of Mars, of Earth, the distant sun ceases to be a mere star and becomes a furnace. The ancient ice, untouched for eons, begins to sublimate, turning directly from a solid into a gas. This process, a gentle warming on a cosmic scale, unleashes the object's soul. Jets of vapor and dust erupt from its surface, creating a vast glowing atmosphere called a coma, which can swell to be larger than a planet. The relentless pressure of sunlight and the solar wind then pushes this material away, sculpting it into two magnificent tails, a bright, curved tail of dust that reflects sunlight, and a fainter, straight tail of ionized gas that glows with its own eerie blue light. This spectacular transformation from a dark, inert lump of ice into a celestial apparition of breathtaking beauty is what defines a comet. It is a spectacle of self-destruction, a gradual unraveling of its own pristine history under the glare of our star. The study of our own comets has taught us about the very water in our oceans, the organic molecules that may have seeded life on a young Earth. They are our messengers from the past, carrying the chemical blueprint of our own origins. But 3I, Atlas was not one of ours. This is the critical, mind-altering distinction. The rock of an asteroid from our system is a piece of our family history. The ice of a comet from the Oort cloud is a sample from our planet's prenatal environment. But the material of an interstellar object, that is a page torn from a completely different book. Its chemistry was not forged in our sun's protoplanetary disk. Its isotopes, the very atomic signature of its elements, were not determined by the supernova that seeded our corner of the galaxy. It is, in the most literal sense, alien. It provides us with a physical sample of the building blocks of planets orbiting another star, a star that could be hundreds or even thousands of light years away. It is a mission of exploration in reverse. We did not have to spend decades and billions of dollars to send a probe to another star system. The other star system, by pure chance, sent a probe to us. This is why the discovery of 3I, Atlas, was not met with fear but with an almost euphoric sense of opportunity. While headlines might speak of a mysterious object from deep space hurtling towards us for scientists, this was not an invader. It was a gift. The initial observations trickled in, painting a preliminary portrait of the visitor. From its brightness, astronomers calculated it was a sizable object, perhaps several kilometers in diameter. And unlike the enigmatic asteroid-like Oumuamua 3I, Atlas was already showing the telltale signs of cometary activity. A faint but distinct coma was beginning to form around its nucleus, a fuzzy halo of gas and dust that confirmed it was rich in volatile ices. This was thrilling. It meant that 3I Atlas was not a dry, inert rock, but a living, breathing cosmic body, a pristine sample from another star's deep freeze. It leaned more towards the reassuring familiarity of Borisov than the baffling strangeness of Oumuamua. The scientific community prepared for a bonanza. As it drew closer to the sun, the increasing heat would act as a celestial blowtorch, peeling back its outer layers and revealing the secrets of its core. Every telescope on and off the planet was poised to analyze the light from its outgassing, to read the chemical barcodes hidden within its vaporizing ice and dust. We were about to get our first detailed glimpse into the chemistry of another world in the making. We were standing on the precipice of a new era of astronomy, an era where we could begin to perform comparative planetology, not just for the worlds in our own solar system, but for the nascent worlds of our galactic neighbors. This single object held the potential to answer some of our deepest questions. Is the chemistry that led to life on Earth common throughout the galaxy? Do other planetary systems form from the same universal recipe? 3I, Atlas, was our Rosetta Stone, a chance to translate the language of another star's creation. The excitement was palpable, a once-in-a-generation opportunity to touch the cosmos beyond our cradle. Scientists charted its course, a graceful, hyperbolic arc that would bring it swinging around the sun before flinging it back out into the interstellar darkness, from whence it came never to return. We had a limited window, a few precious months, to study this traveler before it was gone forever. But as we watched, and as it fell deeper into the gravitational well of our star, this celestial guest began to do something that took everyone by surprise. It wasn't just quietly sublimating. It wasn't just putting on the gentle, predictable show of a well-behaved comet. Something far more violent, far more energetic, was stirring within its ancient frozen heart. The messenger was not just speaking, it was starting to shout, and its chaotic, eruptive message would challenge everything we thought we knew about these visitors from the void. And so the fear began to crystallize, coalescing from a million scattered anxieties into a single terrifying narrative. It spread not through official channels or scientific journals, but through the planet's burgeoning digital nervous system, a wildfire of whispers and warnings that leaped across continents in an instant. This new story, a dark counterpoint to the astronomical wonder of Three-Eye Atlas, claimed that our world was reacting to the visitor. It insisted with growing certainty that the very ground beneath our feet was stirring in violent sympathy with the approaching interstellar guest. Where did such an extraordinary idea come from? It had no single author, no patient zero. It was a crowdsourced dread born in the echo chambers of online forums and nurtured in the fast-flowing currents of social media. A minor tremor in the Pacific Ring of Fire, an event that would have gone unnoticed by the global public just a few years prior, was suddenly Exhibit A. A plume of steam from a long-dormant stratovolcano in Iceland became Exhibit B. A news report of increased seismic activity near a subduction zone in Indonesia was woven into the fabric of the growing myth as incontrovertible proof. Each event, isolated in reality, was presented as a connected dot in a terrifying cosmic conspiracy. Algorithms designed for engagement, not veracity, became the ghost's most powerful allies. They detected a flicker of interest and fanned it into a blaze, feeding a diet of curated panic to those who were already searching for answers. The narrative was seductive because it was simple. It offered a grand, unifying theory for a chaotic world, a single culprit for a planet's groans and shudders. The comet was no longer just a passive traveler. It was an active agent, a celestial puppet master pulling on the tectonic strings of our world. The claims themselves were a tapestry of half-understood science and primal fear. Some spoke of gravitational tides, imagining the comet's pull kneading our planet's molten heart, forcing magma up through the crust like water from a squeezed sponge. Others whispered of exotic electromagnetic fields, theorizing that Three-Eye Atlas was a cosmic magnet agitating Earth's core and triggering a cascade of geological chaos. Videos stripped of their original context were repurposed and shared millions of times. A time-lapse of a 2018 eruption in Guatemala was presented as happening in real time. Satellite imagery of a volcanic gas cloud from years earlier was time-stamped for today. It was a mosaic of fear, assembled from pieces of unrelated truth to create a compelling monolithic lie. And for a world staring into the unknown, a simple lie can be far more comforting than a complex, indifferent truth. But while this digital storm raged, a very different story was being told. It wasn't a story of frantic speculation, but one of meticulous, quiet observation. It was a story being written second by thousands of silent sentinels stationed across the globe, instruments dedicated to a single profound task: listening to the heartbeat of the Earth. In the hushed control rooms of geological surveys from Pasadena to Tokyo, from Naples to Jakarta, the real guardians of our planet's secrets were at work. These are the volcanologists and seismologists, men and women who have dedicated their lives to understanding the immense and ancient forces that shape our world. For them, the Earth is not a silent, solid ball of rock. It is a living, breathing entity, a dynamic system of unimaginable power and complexity, and its language is the language of vibration, of pressure, of chemistry. To suggest that it was being puppeteered by a distant icy wanderer was not just wrong, it was a profound misunderstanding of the colossal scale of the forces at play right here at home. Their work is a stark contrast to the chaotic noise of the internet. It is a slow, patient accumulation of data, a global symphony of measurement played on the most sensitive instruments ever devised. To truly grasp their verdict on Three-Eye Atlas, you have to understand the sheer sophistication of the system they command. Imagine a planetary nervous system. This is the global seismographic network, a web of over 150 state-of-the-art monitoring stations. These are not merely needles scratching on a drum of paper. They are ultra-sensitive sensors, often buried deep underground in vaults of solid bedrock to shield them from the noise of human activity. They can detect the tremor of a distant earthquake, the thunder of a wave crashing on a shore thousands of miles away, and yes, the deep, low-frequency harmonics of magma moving miles beneath a volcano's summit. They feel the Earth's every shudder, translating its raw power into precise data, distinguishing the signature of a tectonic slip from that of a magmatic intrusion with astonishing fidelity. This network never sleeps. It provides a continuous high-fidelity electrocardiogram of the planet, a baseline of its normal rhythm against which any true anomaly would stand out like a scream in a library. For decades, this network has been charting our planet's restless slumber, and its records are the bedrock of modern geology. But feeling the planet's tremors is only one piece of the puzzle. The watchers must also see it breathe. Volcanoes before they erupt often inhale. Magma pushing up from below causes the ground surface to swell to bulge upwards. This movement is often imperceptible to the human eye, a matter of millimeters or centimeters over weeks and months. But it is a critical warning sign, a telltale signal that a system is pressurizing. To see this, scientists turn their gaze to the heavens, employing a fleet of satellites in a technique of breathtaking precision called interferometric synthetic aperture radar, or INSAR. These satellites don't take pictures in the conventional sense. They bounce radar signals off the Earth's surface and measure the return time with an accuracy of billionths of a second. By comparing scans taken on different days, they can create a topographical map of ground deformation, a color-coded chart of the planet's changing shape. A swelling volcano appears on these maps as a psychedelic bullseye of concentric rings, each ring representing just a few millimeters of uplift. It is like a planetary fever chart, revealing the subtle swelling that precedes a geological convulsion. This global unblinking eye gives volcanologists a view that was once the stuff of science fiction, allowing them to monitor hundreds of the world's most dangerous volcanoes, simultaneously from the remote peaks of the Aleutian Islands to the crowded slopes of Mount Vesuvius. Alongside this, they have learned to smell the volcano's breath. As magma rises from the deep earth, it releases dissolved gases, a cocktail of compounds that vent through fissures in the ground called fumaroles, or mix with plumes of steam. The most important of these is sulfur dioxide. A sudden spike in sulfur dioxide emissions is a screaming red flag to any volcanologist, often indicating that a fresh batch of magma has ascended to a shallow depth, depressurizing and releasing its volatile contents. To measure this, scientists deploy an array of tools. Hardy researchers clad in protective gear will venture onto the flanks of active volcanoes to place gas spectrometers directly in the path of plume machines that analyze the chemical fingerprint of the escaping vapors. Far above orbiting satellites carry their own specialized sensors like the ozone monitoring instrument, which can track and quantify sulfur dioxide clouds as they drift across the globe. This ability to sniff the air for geological clues provides another vital layer in the early warning system, another voice in the chorus of data that tells the story of what is happening far beneath the surface. Thermal imaging from space spots developing hotspots, acoustic sensors listen for the deep rumble of rock-shattering explosions, and hydrological monitors track changes in groundwater temperature and chemistry. All of this, the seismic data, the ground deformation maps, the atmospheric gas readings, the thermal signatures, all of it flows into supercomputers, which collate and cross-reference trillions of data points. They build a multi-layered four-dimensional picture of the planet's activity, a living digital twin of our world's geological state. So, what happens when you introduce 3I Atlas into this picture? What does this immense, sophisticated and unflinching system of observation have to say about the claim that this interstellar comet is waking our world's sleeping giants? The scientific community has interrogated this question not with speculation but with data. They have taken the precise known trajectory of 3I Atlas and overlaid it against decades of meticulously recorded global volcanic and seismic activity. They have searched for any statistical fingerprint, any faint signal in the noise, any hint of a correlation between the comet's approach and a change in our planet's behavior. The verdict delivered from every major geological institution on Earth is unequivocal, absolute, and unanimous. There is nothing there. The data visualizations are stark in their clarity. On one side of the screen, you see the smooth, elegant arc of the comet's path as it falls toward the inner solar system. On the other, you see the jagged, chaotic-looking line representing global volcanic eruptions over the past 50 years. The line rises and falls. It has peaks like the dramatic spike after the 1991 eruption of Mount Pinatubo, which blasted so much ash into the atmosphere that it temporarily cooled the entire planet. It has troughs, periods of relative quiet, but its behavior, its rhythm, its statistical average, shows no deviation whatsoever as the comet's track approaches. The number of active volcanoes on any given day, typically between 20 and 40, has not changed. The frequency of major earthquakes, those above a magnitude 6, has not increased beyond the normal, predictable statistical fluctuations. The planet's heartbeat is steady. It is the same restless, powerful, and utterly self-contained rhythm it has maintained for eons. The comet is simply not a factor. The proposed mechanisms for this influence, the whispers of gravity and electromagnetism, collapse under the slightest scientific scrutiny. Let us first consider the force of gravity. It is the grand architect of the cosmos, yes, but its power is a function of mass and a slave to distance. The most powerful gravitational influence on Earth by far is the Sun, which holds our entire world in orbit. The second is our own moon, whose proximity allows it to pull on our oceans, creating the daily tides. In geological terms, these forces are colossal. The relentless tidal pull of the Sun and Moon does in fact exert a tiny, barely measurable stress on the Earth's crust. Compared to these titans, the gravitational influence of 3I, Atlas, is functionally zero. It is an object by astronomical standards of insignificant mass, and it is millions upon millions of miles away. An expert trying to explain the comparison struggles to find an analogy that isn't absurd. Its gravitational pull on our planet's magma is less than the pull of a commercial airliner flying overhead. It is a whisper in a hurricane, a single raindrop on the surface of a raging ocean. It is a force so infinitesimally small that it is utterly lost in the noise of the immense gravitational forces our planet endures every single second of every day. To believe it could trigger an eruption is to believe a butterfly's wingbeat could cause a tsunami. And what of the electromagnetic claims? This idea fares no better. While comets do interact with the solar wind to create a plasma tail and a weak magnetic field, it is a phantom, a ghost of a field when compared to the Earth's own formidable magnetosphere. Our magnetic field is a planetary-scale force shield generated by the churning liquid iron in our planet's outer core. It is a dynamic, powerful bubble that deflects the vast majority of charged particles from the Sun, protecting our atmosphere and all life on Earth. The notion that the feeble magnetic signature of a distant comet could penetrate this shield, travel thousands of miles through the mantle, and somehow agitate the liquid metal core is a fiction. The physics simply does not exist. There is no known mechanism, no plausible theory that could connect these two phenomena. It is a ghost story, woven from the same fear of the unknown that once led our ancestors to see dragons and angry gods in the night sky. The comet is not pulling our planet's strings. It is not shocking its core into a frenzy. It is, from a geological perspective, just a silent passerby, so we are left with a profound disconnect. On one side, we have an intricate global network of sensors and a worldwide consensus of experts who have spent their lives studying our planet. Their data collected over decades is clear nothing unusual is happening. The Earth is behaving exactly as it always has. On the other side, we have a compelling, emotionally resonant story, amplified by the vast machinery of social media that insists the world is breaking apart in response to a cosmic omen. Why does this narrative persist in the face of such overwhelming evidence to the contrary? The answer may lie less in the stars and more within ourselves. We are pattern-seeking creatures. Our brains are hardwired to find connections, to draw lines between dots, to attribute cause to effect. When faced with two spectacular and simultaneous events, the arrival of a mysterious interstellar object and the ever-present dramatic reality of volcanic eruptions, our instinct is to link them. This tendency, known as apophenia, is a powerful cognitive bias. It creates an illusion of causality, where there is only coincidence. The fear, then, is not born from the Earth's response, but from our own. We see a video of a pyroclastic flow, and we times feel times the heat, we times feel times the danger, and we search for a reason that is as grand as the spectacle itself. The mundane reality that this volcano was on a path to eruption for decades due to its own internal plumbing of plate tectonics and magma chemistry feels unsatisfying. It lacks the poetry, the drama of a celestial intervention. The comet provides a villain, a purpose, a story. But a story, no matter how widely believed, does not change the facts. And the facts, written in the language of seismic waves and ground deformation, tell us that the danger is not coming from below. The geological stability of our world is not in question. The scientific consensus is a wall of certainty, a bulwark of data against a tide of fear. The Earth is not reacting to 3I, Atlas, which forces upon us a far more unsettling and urgent question. If the ground beneath our feet is safe from its influence, then what exactly should we be afraid of? The real mystery of this interstellar visitor, it seems, may not be what it does to our world, but what it is in and of itself. And so we are left suspended between an unnerving pattern and a universe governed by unbreakable laws. The synchronicity is undeniable, a chilling alignment of celestial passage and terrestrial fury that speaks to our deepest fears. We see a cosmic messenger racing across the void, and as its ethereal tail grows, so too do the plumes of smoke and ash from Earth's own ancient furnaces. It is a narrative that writes itself, a story of cosmic influence, of a visitor from the dark awakening, a slumbering power within our world. The temptation to connect these dots is immense, a primal urge to find meaning in the sky, to see our destiny written in the passage of comets. But science demands more than a compelling story. It demands evidence. It demands a mechanism. To truly understand if 3I Atlas could be the catalyst for our planet's fiery upheaval, we must first step back from the seductive correlation and ask a much more fundamental question. What does it truly take to shake a world? What kind of force, what scale of power is required to reach across the vacuum of space and physically stir the molten heart of a planet? The answer doesn't lie in the unexplored darkness beyond Pluto. It is written across our sky every single night. Before we can weigh the influence of a fleeting visitor like 3I Atlas, we must first pay homage to the true gravitational titan of our cosmic neighborhood, the celestial anchor that has sculpted our world for 4.5 billion years, our moon. It hangs there, a silent, steady presence, so familiar that we often forget it is engaged in a constant, powerful gravitational dance with our planet. This is not a gentle waltz. It is a profound and relentless force that fundamentally shapes our world. The moon's gravity does not simply pull on the Earth as a single point. It pulls with slightly more strength on the side of the Earth facing it, and with slightly less strength on the side facing away. This difference, this gravitational gradient across our planet's diameter, creates a stretching effect. It is a cosmic tug of war that elongates our world into a subtle ovoid shape, a process we call tidal force. We see its most dramatic effect in our oceans. As Earth rotates beneath these gravitationally induced bulges, the seas rise and fall in a rhythm as old as time. This is the breath of the planet, a slow, deep inhalation and exhalation of water driven by our lunar companion. Every shoreline on Earth is a testament to this power. Every tidal pool, a miniature monument to the moon's unceasing grip. But this force is not limited to the water. The solid rock beneath our feet is also elastic, and it too responds to the moon's pull. The very crust of the Earth rises and falls by as much as 0.5 meter, a solid Earth tide that we cannot feel, but that our most sensitive instruments can detect with unwavering precision. This is the planet itself flexing and straining under the relentless gravitational kneading of its satellite. For eons, this process has acted as a colossal brake, slowing Earth's rotation and lengthening our day from a mere 6 hours in its infancy to the 24 we know today. In this exchange, the Moon has been pushed further away its orbital energy, increasing as Earth's rotational energy decreases. A perfect illustration of the conservation of angular momentum on a system-wide scale. The Moon is not a passive observer. It is an active participant in our world's geological engine. Its constant tidal flexing generates an immense amount of frictional heat within our planet's interior, contributing a small but non-zero fraction to the thermal budget that keeps our mantle convecting and our tectonic plates in motion. Some studies have even suggested a tenuous link, a subtle statistical correlation between the peak tidal stresses of the full and new moon and a slight increase in micro-earthquakes or minor eruptions at specific critically stressed volcanoes. It is a whisper of an influence, a nudge on a system already primed to go. This, then, is our baseline. This is the scale of power we must use as our measuring stick. The Moon, a colossal ball of rock, over 3,400 kilometers in diameter, possessing more than 1% of Earth's own mass, orbits us at a mere 384,000 kilometers. It is a cosmic heavyweight in our own backyard, and its influence, while profound, is still only capable of producing the most subtle and debated effects on our planet's volcanism. Any other celestial body hoping to exert a similar or greater influence must contend with the brutal mathematics of gravity. And here we come to the heart of the matter, to a physical law, as unforgiving as it is elegant, the inverse square law for gravity, and even more critically for this investigation, the inverse cube law for tidal forces. The raw gravitational pull between two objects decreases with the square of the distance between them. If you double the distance, the force drops to 1/4 of its original strength. But tidal forces, the stretching forces that could theoretically molest a planet's interior, are far more sensitive to distance. They decay with the times cube, times of the distance. Double the distance, and the tidal force plummets to a mere 1/8 of what it was. Triple the distance, and it collapses to a 27th. This is gravity's brutal tax on distance, and it is this law that will serve as the ultimate judge and jury for the case against 3I, Atlas. So let us bring the accused to the stand. What is this visitor really? Unlike the solid rocky mass of our moon 3I, Atlas is a comet. Comets are not dense planetary cannonballs. They are celestial phantoms, best described as dirty snowballs, or more accurately, snowy dirt balls. They are porous, loosely packed agglomerations of water ice, frozen gases like carbon dioxide and methane, and a significant amount of dust and rock. Their structure is fragile, more akin to cosmic meringue than solid granite. The nucleus of 3I, Atlas, the solid body at its heart, is estimated to be perhaps 10 kilometers across. While that may sound large, its low density and fluffy composition give it a staggeringly small mass. The total mass of 3I Atlas is estimated to be in the region of 1 trillion tons. It is a number so large as to be meaningless to us, yet in cosmic terms it is utterly insignificant. The mass of our moon is 73 times quintillion times tons. That's 73 followed by 18 zeros. To put that into perspective, you would need more than 73 million comets identical to 3I, Atlas, just to equal the mass of our moon. It is a comparison between a single grain of sand and an entire mountain range. This colossal disparity in mass is the first and perhaps most damning piece of evidence against its capacity to influence our world. It simply doesn't have the gravitational heft, but the case against it grows even more overwhelming when we consider the second variable, distance. At its closest approach, 3I, Atlas, will pass our planet at a distance of approximately 116 million kilometers. This is a safe pass, a comfortable margin in celestial terms. But let us compare that to our benchmark. The moon orbits at 384000 kilometers. This means the comet, at its very nearest, will still be more than 300 times farther away from us than the moon is, on average, every single day of our lives. Now we must apply the unforgiving logic of the inverse cube law. If a comet of equal mass to the moon were 300 times farther away, its tidal influence would be reduced by a factor of 300 cubed. That's 300 times 300 times 300, which equals 27 million. Its tidal force would be 27 million times weaker than the moon's. But 3I Atlas is not the moon's equal in mass. As we established, it is more than 73 million times less massive. So we must combine these two factors. We take the already minuscule influence, weakened by a factor of 27 million due to distance, and we must then divide that by another 73 million to account for its pathetic mass. The result is a number so infinitesimally small, it borders on the purely theoretical. The tidal force exerted by comet 3I, Atlas, on the Earth at its absolute closest approach will be roughly 2 times, quadrillion times weaker than the tidal force exerted by our own moon. 2 quadrillion. That is a 2 followed by 15 zeros. It is a degree of influence so negligible that it is utterly lost in the noise of the solar system. The gravitational pull of a commercial airliner flying overhead exerts a more significant tidal stress on your body than 3I, Atlas, will exert on the entire planet Earth. The subtle gravitational shifts caused by the planet Jupiter in its distant orbit are thousands of times more powerful. The Sun, of course, exerts its own tidal force on the Earth, about 46% as strong as the Moon's. Every day, our planet is bathed in a complex sea of gravitational pulls from every object in the solar system. A constant symphony of pushes and pulls that it has been accustomed to for its entire existence. Against this backdrop, the arrival of 3I Atlas is not a cymbal crash. It is not even the sound of a pin dropping. It is the equivalent of a single dust mote falling silently in a thundering avalanche. The physics is not ambiguous. It is not open to interpretation. It is an absolute mathematical certainty. 3I Atlas is physically incapable of causing any geological effect on our planet. It cannot raise tides, it cannot stretch our crust, it cannot stir our mantle. Its passage is, from a geophysical perspective, a complete non-event. But what if there is another way? Could the comet's influence be more subtle? Perhaps it is not about brute force, but about resonance. This is the idea that even a small periodic push, if timed perfectly with an object's natural frequency, can create a large vibration. It is the principle that allows a singer to shatter a crystal glass with just their voice, or a troop of soldiers to collapse a bridge by marching in step. Could 3I Atlas, as it passes, be striking some resonant frequency within the Earth's magma chambers, ringing the bell of our planet and triggering eruptions? It is an intriguing idea, but one that also collapses under scrutiny. Resonance requires a sustained periodic force, a series of pushes delivered at just the right rhythm. 3I Atlas provides the exact opposite of this. it is a transient event. The comet is screaming through the inner solar system at a velocity of over 1,500,000 kilometers per hour relative to Earth. Its period of closest approach is fleeting, lasting only a few days or weeks before it recedes back into the darkness. It is a single, incredibly weak pulse of gravity, not a sustained vibration. It is the equivalent of trying to shatter a wine glass by having a fly buzz past it once. The input of energy is too brief, too weak, and delivered at the wrong frequency to have any effect. The Earth's geological systems, which operate on timescales of thousands and millions of years, are simply too immense and too sluggish to respond to such a fleeting and insignificant gravitational whisper. And so the scientific verdict becomes clear, delivered not by opinion or belief, but by the cold, hard calculations of celestial mechanics. We have built the models. We have run the simulations. We have plotted the trajectories and calculated the forces down to the last decimal point. On screens in laboratories and observatories across the globe, the story is the same. The digital Earth remains unmoved by the approach of the digital comet. The simulated magma chambers remain quiescent. The lines on the graphs measuring planetary stress do not deviate by even a hair's breadth. The consensus is unequivocal. The link between the arrival of 3I, Atlas, and the surge in global volcanism is a phantom, a ghost born of our pattern-seeking minds. It is a compelling coincidence, but a coincidence nonetheless. The object in the sky is not our culprit. It is a scapegoat, a distraction from a much deeper and more intimate truth. We have been looking for an answer in the cold, distant void, pointing our fingers at an alien intruder. We have imagined a force from without a disruption to the natural order. But the laws of physics have slammed that door shut and locked it. They have forced us to abandon the cosmic explanation and to turn our gaze away from the stars. They compel us to look back at our own world not as a passive victim of celestial forces, but as a dynamic and powerful system in its own right. The truth, it seems, is not out there. The disturbance is not coming from millions of kilometers away. The ghost in the machine was never from the outside. The call, we are now forced to realize, has been coming from inside the house all along, and yet for millions, the case was far from closed. The clean, cold facts of astrophysics, presented with certainty, somehow failed to extinguish the fire. Scientific reason, it turned out, was like water on a grease fire. Instead of dousing the flames, it seemed only to make them leap higher, to spatter and spread in unpredictable directions. The debunking, so clear and logical, addressed the physics of the comet, but it completely missed the true source of the phenomenon. It failed to account for a force far more complex and mercurial than gravity, a force found not in the vacuum of space, but within the 3-pound universe of the human brain. To understand why the fear of 3I, Atlas, grew, even as the evidence against it mounted, we must turn our gaze away from the telescope and toward the mirror. We have to look inward into the very architecture of our own minds, where ancient survival instincts clash with the complexities of the modern world. Our brains, after all, are not precision instruments designed to calculate orbital mechanics or analyze seismic data with cold objectivity. They are pattern-matching machines forged over eons on the sun-drenched savannas and in the shadowed forests of our ancestors. That prehistoric legacy means you are hardwired for a peculiar and powerful tendency, pareidolia. It's the reason you see a face in the craters of the moon, a dragon in the shape of a passing cloud, or a figure in the static of a television screen. Your mind is desperately trying to impose meaningful order on random data to find a signal in the noise. For our ancestors, this was a life-saving feature, not a bug. The rustle in the grass might just be the wind, but assuming it's a predator and being wrong costs you nothing. Mistaking a predator for the wind, however, costs you everything. So, evolution selected for brains that are hypersensitive to patterns, even phantom ones. We are the descendants of the perpetually anxious, the ones who saw faces in the dark and lived to tell the tale. Today, that same ancient software is running on the advanced hardware of the 21st century, and it sees the approach of 3I, Atlas, not as a celestial coincidence, but as a deliberate and menacing omen. It scans the globe for data points for any hint of geological unrest. An earthquake in the Philippines, a volcanic plume in Iceland, a tremor off the coast of Japan. These are not seen as the planet's normal chaotic breathing. Instead, they become the rustle in the cosmic grass. They are perceived as points on a line, a terrifyingly clear pattern connecting the comet's journey through our solar system with the groaning of the Earth beneath our feet. This instinct to find patterns is then supercharged by an even more insidious cognitive trap: confirmation bias. It is one of the most tenacious and universal quirks of human psychology, affecting everyone from the casual observer to the dedicated scientist. It is the invisible filter through which we all view the world, a lens that subtly bends reality to fit our pre-existing beliefs. Once a belief takes root, your brain doesn't act like an impartial judge, weighing all available evidence. Instead, it becomes a determined lawyer, selectively searching for any shred of information that supports its case, while simultaneously dismissing, discrediting, or ignoring anything that contradicts it. If you have come to believe, even subconsciously, that 3I, Atlas, is a harbinger of doom, your mind will diligently begin to build that reality for you. Every news report of a minor eruption, no matter how remote or routine, becomes Exhibit A. It's not just a volcano erupting, it's the volcano erupting times while the comet is approaching asterisk. The two events become fused in the mind, creating a causal link where none exists. Conversely, the weeks of geological quiet, the thousands of seismometers reporting nothing but silence, go completely unnoticed. They are the contradictory evidence that your internal lawyer expertly waves away. The reasoned statements from geologists are reinterpreted not as fact, but as deception, part of a concerted effort to prevent public panic. The bias creates a closed loop, an intellectual fortress, where every new piece of information, confirming or otherwise, is simply used to reinforce the existing walls. The more the scientific establishment pushes back, the more it proves to the believer that they are onto something big, something the authorities desperately want to hide. Beneath these cognitive shortcuts lies a deeper, more emotional human need, the desperate search for simple explanations in an overwhelmingly complex world. We live suspended in a universe of staggering complexity, governed by quantum mechanics, general relativity, and geological forces that operate on timescales of millions of years. The planet we inhabit is a dynamic, violent, and fundamentally unpredictable system. The truth is that earthquakes and volcanic eruptions happen for a dizzying array of reasons. The slow, grinding dance of tectonic plates, the upwelling of mantle plumes from the core, the intricate plumbing of magma chambers deep within the stone crust. These processes are impersonal, chaotic, and utterly indifferent to us. This is a terrifying and deeply unsatisfying reality for a species that craves narrative, purpose, and agency. The story of 3I, Atlas, in its terrifying simplicity, offers a strange kind of comfort. It transforms the vast, meaningless chaos of geology into a clear, understandable story with a protagonist and an antagonist. The Earth is not just creaking under its own immense pressure. It is being times attacked, asterisk. There is a villain in the sky, a single, identifiable source for our anxiety. This narrative, though frightening, is paradoxically easier to process than the ambient, directionless dread of living on a volatile planet. It provides a focal point for fear. It is a story, and human beings are creatures who have always made sense of the world through stories. The myth of the cosmic cannonball, aimed at our world's geological weak points, is far more compelling, far more times human times, than a sober lecture on plate tectonics. It gives a name and a face to the formless anxiety of our times, and for many, that is a bargain worth making, even if it means sacrificing the truth. Into this fertile ground of human psychology, a powerful new accelerant has been poured: the digital architecture of our modern lives. Social media and the algorithms that govern it have created the most efficient system for the dissemination of misinformation in human history. These systems are not designed to discern truth from falsehood. They are not programmed for accuracy, nuance, or scientific validity. Their sole overarching purpose is to maximize one thing: your engagement. They are built to capture and hold your attention for as long as possible, and their complex code has learned a simple, primal truth about human nature. Nothing captivates our attention like fear, outrage, and the tantalizing hint of a hidden conspiracy. When you first show a fleeting interest in the 3I Atlas theory, perhaps by clicking a sensational headline or watching a short dramatic video, the algorithm takes note. It doesn't register your curiosity as a search for truth. It registers it as a successful engagement. Its immediate response is to serve you more of the same, but with escalating intensity. Your feed begins to subtly transform. You are shown more videos of volcanic eruptions, more articles breathlessly connecting the comet to seismic activity, more posts from communities of like-minded believers who share your growing unease. This creates a powerful and deeply distorting informational feedback loop, known as an echo chamber. The algorithm isn't trying to deceive you maliciously. It is simply giving you what its data suggests you want. Dissenting opinions, scientific debunkings, and sober explanations are filtered out, not because they are false, but because they are less engaging. They don't generate the same emotional spark, the same number of clicks, shares, and comments. You are steadily guided into a curated reality, where the evidence for the comet's malevolence appears to be overwhelming and ubiquitous. Everyone you encounter in these digital spaces shares your belief, strengthening your conviction. Any lingering doubt you may have had is eroded by the sheer volume of reinforcing content. You feel less like a lone individual with a fringe idea and more like a member of an enlightened group who has discovered a terrifying hidden truth. This digital ecosystem becomes a hothouse for fear, a place where a spark of curiosity can be algorithmically fanned into an inferno of unwavering belief, completely insulated from the countervailing winds of reality and fact. The digital world ceases to be a window onto the real world, and instead becomes a mirror, reflecting and amplifying our own deepest anxieties back at us, with terrifying clarity and conviction. The result is a global crowdsourced effort to construct a terrifying but utterly false mosaic. The raw materials for this construction are the endless, disconnected bits of geological data that our planet produces every single day. There are, on average, 50 earthquakes around the world daily that are strong enough to be felt. There are roughly 20 volcanoes actively erupting on any given day. These are baseline statistics, the normal rhythmic pulse of a living planet. In a pre-internet age, most of this activity would have remained localized, a footnote in a regional newspaper or a brief mention on a late-night news broadcast. But today, every single event, no matter how minor or remote, is instantly available, decontextualized, and ready to be weaponized. A 4.8 magnitude tremor in southern Italy, a steam plume from Mount Ibu in Indonesia, a deep-sea volcanic vent discovered off the coast of Oregon. Viewed in isolation, they are scientifically mundane, but within the 3I Atlas narrative, they are meticulously gathered and curated. They are cherry-picked from the torrent of global data and presented as undeniable proof of a coordinated, escalating assault. Online communities become clearinghouses for these events, with users posting maps covered in red dots, creating timelines that purport to show the increasing frequency of disasters, and sharing videos of billowing ash clouds set to ominous music. They are connecting the dots, but the picture they are drawing is a phantom. They are mistaking the increase in our times awareness, times of geological events, for an increase in the events themselves. We are monitoring the planet with more sensitivity than ever before, and we are sharing that information with more speed than ever before. This creates the powerful illusion of a world suddenly shaking itself apart. The narrative creates a gravitational pull of its own, drawing in unrelated phenomena and binding them to the central story. Solar flares, unusual weather patterns, even power outages are absorbed into the growing mythos, each one cited as another piece of the puzzle. What the scientific community sees as random stochastic noise, the believers see as a perfectly orchestrated symphony of destruction. Each cherry-picked event becomes another brushstroke in a masterpiece of fear, a sprawling and internally consistent narrative that feels more real, more immediate, and more compelling than the complicated, messy truth. It is a story built from facts, but it is a story that tells a profound lie, one that overshadows the patient, methodical work of science and replaces it with something far more potent and far more dangerous. The real threat was never the comet itself, but the schism. It was revealing a growing chasm in our shared reality, a divide between those who trusted the scientific method and those who had come to trust the narrative being woven in the digital darkness. And as 3I Atlas continued its silent journey through the void, that chasm was about to widen with consequences that no one could yet predict. Amidst the cacophony of speculation, as headlines screamed and digital forums ignited with prophecies of doom, a very different story was being written. It wasn't a story of fear, but of focus. It wasn't scrawled in panicked keystrokes, but meticulously recorded in the silent, steady stream of data flowing from the eyes and ears of humanity. While the world looked for a villain in the sky, a global fellowship of scientists was engaged in a profound two-front investigation, looking both outward into the abyss and inward into the heart of our own planet. They were separating the signal from the noise, tuning out the roar of anxiety to hear the delicate whispers of truth. The climax of this extraordinary encounter with 3I Atlas would not be an explosion or a cataclysm. It would be a revelation, a quiet, breathtaking moment when meticulous inquiry triumphed over primal fear, unveiling the genuine, spectacular wonders that had been hiding in plain sight all along. The first front in this campaign for clarity was pointed toward the heavens, at the enigmatic messenger itself. To truly understand 3I Atlas, to read the secrets it carried from its long-lost home, astronomers had to perform a cosmic autopsy from 100 million miles away. Their primary tool was not merely a lens, but a prism, an instrument capable of dissecting light itself. Through the demanding science of spectroscopy, the faint ancient sunlight reflecting off the comet's core and its burgeoning coma was captured, collected by immense mirrors, and painstakingly split into its constituent colors, a rainbow, etched with dark, impossibly thin lines. These lines are a fingerprint, a unique chemical barcode imprinted on the light by the very atoms and molecules that absorbed it. Each element, each compound, steals a specific sliver of the spectrum, and in that theft, it betrays its presence. For weeks, the great telescopes of the world, the Very Large Telescope in Chile, the Keck Observatory in Hawaii, even the repurposed gaze of Hubble in orbit, stared unblinkingly, gathering every precious photon. Slowly, as the data accumulated, the ghost began to take form. The spectrographs revealed a familiar, life-giving signature, the deep absorption bands of water ice, vast quantities of it, the fundamental ingredient of our own world. This was the fuel for the comet's spectacular outbursts, the frozen reservoir being vaporized by the sun's relentless glare. But woven within that familiar signal were alien threads. They found the unmistakable spectral lines of carbon monoxide and carbon dioxide, frozen so solid they would be rock-hard on Earth, but here sublimating gently into the vacuum. They detected nitrogen, a key component of our atmosphere, locked in its own icy prison. And deeper still, within the dust grains shed by the nucleus, they found the signature of silicates, the very stuff of rock and sand, but with subtly different crystalline structures than those common in our solar system, hinting at a formation under different pressures and temperatures. Most tantalizing of all were the faint but persistent signals of complex organic molecules, not life but its precursors. Cyanogen, the same molecule found in the tails of our own comets, was there. But so too were traces of more complex hydrocarbons, chains of carbon and hydrogen that form the backbone of life as we know it. 3I Atlas was not a harbinger of death. It was a delivery vehicle, a time capsule, carrying the raw primordial ingredients from which worlds are made. It was a tangible piece of another star's protoplanetary disk, a fossil from a stellar nursery we may never see directly. The composition told a story of a birthplace that was likely colder and perhaps further from its parent star than where our own comets formed a place where exotic ices like frozen nitrogen could readily condense and survive. For the first time, we weren't just guessing what other solar systems were made of. We were holding a piece of one, analyzing its atomic makeup and confirming that the fundamental chemistry for life is not unique to our quiet corner of the galaxy. It is universal. Parallel to this chemical decoding was the monumental task of charting the wanderer's path, a feat of celestial mechanics that required unprecedented precision. Its trajectory was the ultimate clue to its identity. If it were one of ours, a long-lost child of the Oort cloud, it would travel on a vast looping ellipse, a gravitational leash, however long, still tethering it to our Sunday. But an outsider would be untethered. It would approach and depart on a unique geometric curve known as a hyperbola, a path that screams of a one-time visit, a gravitational flyby with no return ticket. To prove this, astronomers deployed a global network of telescopes, creating a planetary-scale sensor array. They measured the comet's position against the backdrop of distant stars night after night, using the principle of parallax, the same effect you see when a nearby object seems to shift against a far-off background as you move. By combining observations from observatories separated by thousands of miles, they could triangulate 3I Atlas's position with astonishing accuracy. Into this river of positional data, they added measurements of its velocity using the Doppler effect. As the comet raced toward us, the light it reflected was infinitesimally compressed, shifted toward the blue end of the spectrum. As it began to curve away, that light would stretch, shifting toward the red. This cosmic radar gun provided the final critical variable. Powerful supercomputers at NASA's Jet Propulsion Laboratory and the European Space Agency churned through the torrent of data, running complex orbital determination algorithms. They accounted for the gravitational pull of the Sun of Jupiter of every major body in our solar system. They even factored in the tiny, unpredictable nudges the comet gave itself each time one of its volcanic jets of sublimating gas fired off. The result was unambiguous, a mathematical certainty that sent a shiver of pure discovery through the astronomical community. The comet's trajectory was not just hyperbolic, it was wildly, radically so. Its eccentricity, the measure of how much a path deviates from a perfect circle, was far greater than any object ever recorded. This was no returning native. 3I Atlas had fallen toward our Sun from a direction that belonged to no known structure in our solar system, moving with a velocity that our Sun's gravity alone could never have imparted upon it. It had been drifting through the cold, dark void between the stars for perhaps hundreds of millions of years, a lonely traveler ejected from its home system by some ancient gravitational chaos, likely the frantic dance of giant planets, settling into their own orbits. It was a refugee, a message in a bottle thrown from a faraway shore, and its speed and path were the definitive proof. The so-called volcanic eruptions were not a sign of aggression, but simply the object's ancient frozen body awakening, crying out in a cloud of gas and dust as it felt the warmth of a star for the first time in an unimaginable eon. While one global network stared into space, another was listening intently to the deep, resonant heartbeat of the Earth. The second front in the war on misinformation was a terrestrial one, fought in the quiet data centers and analysis labs of seismologists and volcanologists around the world. The hypothesis being peddled online was simple and seductive. A mysterious object approaches, and our planet trembles in response. To the untrained eye, observing a news report of an earthquake in Indonesia, followed by an eruption in Iceland while 3I Atlas was in the headlines, the connection seemed plausible, even intuitive. But science demands more than intuition. It demands evidence, and the search for that evidence involves one of the most sophisticated planetary monitoring systems ever conceived. Imagine a web spun not of silk but of silicon and steel, wrapping the entire globe. At over 2,000 nodes in this web are the instruments of the global seismographic network, ultra-sensitive seismometers capable of detecting vibrations smaller than the width of an atom. Some are buried deep in abandoned mine shafts, shielded from the noise of human activity. Others rest silently on the abyssal plains of the seafloor, listening to the groans of the crust. These instruments don't just record the violent shaking of a major earthquake. They provide a continuous, high-fidelity electroseismic cardiogram of the planet. They track the subtle tremors of magma moving miles beneath a slumbering volcano, the deep hum of ocean waves pounding on distant coastlines, and the faint seismic whispers of shifting tectonic plates. This network is complemented by an armada of satellites in orbit. GPS stations scattered across the continents measure the imperceptible creep and strain of the Earth's surface, tracking land as it rises, sinks, or stretches by mere millimeters a year. The telltale signs of building stress along a stated fault line or the swelling of a magma chamber. Other satellites equipped with sophisticated radar, like that on the Sentinel constellation, use a technique called INSAR, interferometric synthetic aperture radar. They bounce radar signals off the surface and compare the return echoes over time, building exquisitely detailed maps of ground deformation, literally watching the planet breathe. Add to this the infrasound detectors that pick up the low-frequency sound waves of eruptions, the gas-sniffing sensors that measure volcanic sulfur dioxide from space, and the on-the-ground geological surveys, and you have a picture of a world under constant, rigorous surveillance. With this incomprehensible ocean of data, scientists could finally put the 3I Atlas hypothesis to the ultimate test. The question was a simple one of correlation versus causation. Was there a statistically significant global increase in seismic or volcanic activity that tracked with the comet's decreasing distance from Earth? The process was methodical. Researchers compiled decades of baseline data, establishing the normal rhythm of the planet's geological activity. Earth is never quiet. On any given day, dozens of small earthquakes occur, and between 20 and 50 volcanoes are actively erupting somewhere on the globe. This is the normal state of a geologically alive planet. The key was to see if the approach of 3I Atlas altered this baseline, if it caused a deviation from the statistical norm. They plotted the comet's proximity on one axis, and the global volcanic output, measured in energy released or volume of material extruded on another. They did the same for seismic energy, charting the frequency and magnitude of earthquakes worldwide. As the graphs took shape, the truth became starkly, undeniably clear. There was no correlation, none. The line representing Earth's geological activity was a jagged, chaotic scribble dictated by its own internal logic, showing random peaks and valleys that bore no relationship whatsoever to the smooth, predictable curve of the comet's approach. The eruption in Iceland that had caused such a stir, its timing was a complete coincidence. INSAR data and GPS measurements showed the ground around the volcano had been swelling for 18 months, a classic sign of a magma chamber slowly refilling from deep within the mantle. It was a process driven by the inexorable pulling apart of the mid-Atlantic ridge, a tectonic engine that has been running for 200 million years and cares nothing for passing celestial objects. The earthquake in the Pacific Ring of Fire seismologists could trace its origins to the relentless subduction of the Pacific Plate beneath the Eurasian Plate, a collision happening at the speed your fingernails grow. Stress had been accumulating along that specific fault segment for over 75 years. A gravitational debt that was always going to be paid with or without a cosmic audience. In case after case, the story was the same. Every geological event attributed to the comet had a clear, well-understood, and entirely terrestrial cause. The apparent pattern was a phantom, an illusion, born of a psychological bias known as apophenia, our innate human tendency to find meaningful connections in random data. We are pattern-seeking creatures, and in the face of two spectacular simultaneous events, a celestial visitor and a restless Earth, our minds desperately want to draw a line between them. But the cold, hard, beautiful logic of the data showed no such line existed. The gravitational pull of 3I, Atlas, even at its closest approach, was calculated to be less than that of a commercial airliner flying overhead. It couldn't rattle a window pane, let alone stir a continent-sized tectonic plate. Here, then, was the dual climax of our encounter. As we looked up, the fuzzy specter of doom resolved into a messenger of cosmic wonder, an interstellar artifact carrying the chemical recipe for other worlds, confirming that the building blocks of our existence are scattered liberally throughout the cosmos. Its fiery outbursts were not acts of aggression, but the simple physics of ancient ice meeting sunlight, a beautiful and harmless process of awakening. And as we listened to our own world, the chaotic rumbles of fear resolved into the understandable symphony of a living planet. The eruptions and earthquakes were not symptoms of a cosmic curse, but the steady, powerful pulse of Earth's own inner life, the workings of a heat engine deep in its core that has shaped our world for billions of years. The triumph was not in surviving a threat that never was, but in the power of the human mind to stare into the vastness of space and the complexity of our own planet, to choose meticulous inquiry over panicked speculation, and to find not a monster in the dark, but a deeper, more profound understanding of our place in the universe and the dynamic, magnificent nature of the home we stand on. The true revelation of 3I, Atlas, was a lesson in perspective, a reminder that the most awe-inspiring stories are not the ones we invent in fear, but the ones we painstakingly uncover through the unwavering pursuit of knowledge, undefined. And so the phantom recedes. We watch its light, now impossibly faint, as it falls away from us, a traveler returning to the silent, sunless depths from which it came. The frantic energy that once surrounded its arrival has dissipated, replaced by the quiet hum of data analysis and the profound stillness of understanding. You can almost feel the collective breath we as a planet held in our chests finally being released. It's a release that marks the end of a very particular kind of journey, not just for 3I Atlas, but for us. We began this story in a state of alarm, caught in a digital tempest of sensational headlines and fearful speculation. The narrative was simple, powerful, and deeply unsettling. A monstrous, unknown object torn from another star was hurtling towards our home, its volcanic heart awakening in a series of violent, unpredictable blasts. It was a story perfectly crafted for our anxious age, a tale that fed on our deepest insecurities about the vast, uncontrollable forces of the cosmos. The initial images, blurry and indistinct, became a canvas onto which we projected our fears. Every pixelated flare-up was interpreted as a sign of aggression, every change in trajectory a harbinger of doom. The language used was that of invasion, of threat, of an impending chaotic reckoning. We were told to look up in fear, to see not a celestial wonder but a cosmic bullet with our name on it. This narrative, amplified by algorithms designed to provoke and retain our attention, spread faster than the object itself. It created a powerful gravitational field of its own, pulling public discourse into a vortex of anxiety and misinformation, where the loudest, most frightening voices often drowned out the cautious, measured tones of genuine inquiry. This is the treacherous terrain we all must navigate now, a world saturated with information yet starved for wisdom. We are drenched in data but parched for context. The story of 3I, Atlas, became a case study in this modern dilemma. The initial fear was not born of malice, but of the unknown expertly exploited by a media ecosystem that prioritizes clicks over clarity and engagement over education. It was a digital ghost story told around a global campfire, and for a time we were all mesmerized by the terrifying shadow it cast. The fear was real, the uncertainty was palpable, but it was not the truth. It was merely the first distorted echo of a far more complex and beautiful reality, a reality that could only be brought into focus by the most powerful tool humanity has ever devised for dispelling shadows, the scientific process. That process began not with a dramatic proclamation, but with a quiet promise to observe, to measure, to question, and to doubt. It is a promise kept by a global network of individuals who have dedicated their lives to the patient, meticulous work of cosmic forensics. They are the sentinels of the night sky, the keepers of the light. For them, 3I Atlas was not a monster, it was a mystery. And a mystery is an invitation to engage, to learn, to push the boundaries of our knowledge. This is where the real drama unfolded, not in speculative news reports, but in the quiet hum of observatory domes turning against the starry dark. It played out in the silent streams of data, flowing from telescopes on remote mountain peaks and in the lonely orbits high above our world. It was a drama of collaboration, of scientists across continents and cultures, sharing findings in the dead of night, their computer screens the only light in the room. They argued, they debated, they refined their models. They built a picture of this object not from fear but from evidence. Each photon captured was a word, each spectral reading a sentence, in a language we were just beginning to decipher. This process is often slow, frustrating, and filled with dead ends. It offers no easy answers, no satisfyingly simple certainties. Science speaks in probabilities, in confidence intervals, in peer-reviewed arguments. It corrects itself. It evolves. It embraces uncertainty as the starting point for discovery, not the end point of fear. Think of the sheer, unyielding effort it took. While the world was reacting to headlines, astronomers were painstakingly teasing apart the faint light of this interstellar visitor. They used spectrographs to dissect its chemical breath, looking for the telltale fingerprints of elements and molecules. They measured the subtle push of its outgassing, the gentle exhalation of ancient volatiles warmed by our sun for the first and only time. They realized the volcanic eruptions were not signs of a menacing power, but the death throes of exotic ice's compounds, unlike the familiar water ice of our own comets. These were cryovolcanoes, frigid geysers erupting with nitrogen, carbon monoxide, and other substances forged in the frigid cradle of another star system, a system that may have lived and died before our own sun had even ignited. This is the immense, painstaking work that stands as a bulwark against the tide of misinformation. It is a process of disciplined curiosity. It requires that we hold our own biases up to the light, that we are willing to be wrong, that we value a well-supported question more than a poorly supported answer. In an age that demands instant gratification, the scientific method demands patience. In a culture that rewards absolute certainty, it offers progress through doubt. It is our most reliable compass in the wilderness of the unknown, and by following it we transformed 3I, Atlas, from a symbol of cosmic dread into a vessel of profound insight. We turned away from the frightening ghost story and began to read the intricate, beautiful message it had carried across the interstellar void for millions of years. And what a message it was. This object, we now understand, is a priceless artifact, a messenger from a place we can never visit. It is a fragment of a world story, a story that began light years away and eons ago. Its very existence confirms a deep and thrilling truth, that the building blocks of worlds are not unique to our solar system. The universe, it seems, is astonishingly profligate in its creation. The same raw materials, the same physical laws that built our Earth are at work around other stars, building other planets, other possibilities. 3. Atlas is a physical sample of one of those distant construction sites delivered directly to our doorstep. It's a cosmic core sample drilled from the crust of an alien planetesimal and sent on an impossibly long journey. Inside its frozen heart, it carries the chemical memory of its birth nebula, the specific ratios of its isotopes, the unique blend of its frozen gases are like a genetic marker tying it to a parent star and a planetary system we will likely never see. This is no longer just astronomy. This is interstellar archaeology. We are sifting through the remains of a foreign system, learning about its temperature, its chemistry, its violent youth. The volcanic eruptions that once terrified us are now seen for what they truly were, a library of information opening itself to us. As the sun's warmth peeled back its outer layers, it revealed chapter after chapter of its history, a history written in the language of physics and chemistry. This shift in perspective is the entire point. We have the capacity within us to make this transformation, to move from primal fear to informed wonder. It requires that we engage our critical faculties, that we question the sources of our information, and that we develop a literacy for the language of science. We must learn to distinguish between the carefully constructed edifice of scientific consensus and the flimsy scaffolding of baseless speculation. We must become comfortable with complexity and nuance, and resist the allure of dangerously simple answers to profoundly complex questions. The story of our encounter with 3I, Atlas, is a lesson in cosmic citizenship. It teaches us that our first reaction to the unknown need not be fear. It can be curiosity. It can be awe. It can be the humble recognition that there is more to learn. This interstellar visitor did more than just expand our knowledge of the cosmos. It held up a mirror to us. Our reaction to its arrival revealed our anxieties, our societal fractures, our relationship with truth itself. The initial wave of panic was a symptom of a deeper disconnect, a gap between the frontiers of human knowledge and the public understanding of it. Closing that gap is one of the great challenges of our time. We must champion the institutions and the individuals who dedicate themselves to the slow, steady work of discovery. We must foster a culture that values evidence over emotion and inquiry over ideology. The universe is filled with wonders that are far more spectacular, far more mind-bending than any fiction we could invent, but we can only appreciate them if we are willing to do the work of understanding. The true marvel of 3I Atlas was never the threat it might pose. The true marvel is that it exists at all. That a piece of another solar system, after a journey that beggars the imagination, could pass through our tiny cosmic neighborhood. That we, a species confined to a fragile sliver of biosphere on a single small planet, could have evolved to a point where we can not only spot such a visitor, but reach out with our instruments and read its story. This is the miracle. Not the object itself, but our ability to comprehend it. Our capacity to look at a faint smudge of light millions of miles away and deduce the nature of a star system light years distant. That is one of the most astonishing achievements of the human intellect. It is a testament to our relentless, unyielding curiosity, the same curiosity that led our ancestors out of caves to chart the stars, and the same curiosity that will one day carry us to them. So, as 3I Atlas continues its lonely voyage back into the cold and the dark, it leaves behind more than just a trail of exotic dust. It leaves behind a lesson. It reminds us that the universe is not hostile, but it is indifferent. It operates on principles we can uncover and understand. It reminds us that our place within it is both infinitesimally small and immeasurably precious. And it reminds us that the greatest discoveries are often found at the intersection of humility and audacity. The humility to admit what we do not know, and the audacity to believe we can find out. The cosmos is a book of infinite pages, and we have only just begun to read the preface. Every new discovery, every interstellar visitor allows us to turn another page. We are explorers on the shore of a cosmic ocean, and objects like 3i, Atlas, are the strange, beautiful shells that wash up at our feet, hinting at the vast, unexplored wonders that lie in the deep. They challenge us, they inspire us. They compel us to build better ships, to draw more accurate maps, and to ask bolder questions. The fear has passed, the panic has subsided, and what remains is a profound sense of gratitude. Gratitude for the glimpse we were given into a world beyond our own. And a renewed appreciation for the power of the human mind to transform the terrifying unknown into the knowable and the beautiful. The night sky is not a source of dread. It is a laboratory, a museum, a cathedral, and our invitation to explore it is written in the light of a billion stars. The journey of 3i, Atlas, through our solar system is over, but ours, the human journey toward understanding, has only just begun. There will be other visitors. The darkness between the stars is not empty, and when the next one comes, we will be ready, not with fear, but with wonder and with the unwavering light of science to guide our way.